a geared centrifugal pump, a new high volume artificial lift method. I work for ConocoPhillips. My author, Bruce Morrow, works for Harrier Technology. He is the one, and his company brought the concept to ConocoPhillips. Mike Berry, the other co-author, I have him working today in Odessa on another technology development program. I work for ConocoPhillips. My job is pretty much to provide technical assistance throughout our company. I'm a production engineering advisor that is divided up into two areas. Provide artificial lift assistance, technical service throughout the company. The other part is developing technology for the needs of ConocoPhillips in the area of artificial lift. So the geared centrifugal pump is one of those. So what is the geared centrifugal pump? It's a mechanically driven centrifugal pumping system. There's no downhole electrical components. So we have a rod string that drives an ESP centrifugal pump through a 7-to-1 gearbox or transmission or speed increaser. The purpose of that is for a rod string driving at 500 RPMs, it will turn to ESP at 3,500 RPMs. And we hope to be able to obtain ESP capacity with rod pumping efficiency. So the components that you have on the GCP, let's start from the bottom, going all the way to the top. At the very bottom, you have a stinger and a gas anchor. This could be run as is shown in the diagram, that I can have the intake to the pump through the stinger way below the perforations. So you can have a small diameter stinger extending down below the perforation. That connects to the centrifugal pump. So it's a bottom intake system. The pump then is connected to a lower shroud section with a thrust bearing. It's a pin shaft on the pump connected to the seal, and the thrust is carried in the lower seal section. The next section is the transmission or the speed increaser. The next section is the upper shroud or seal. Then you have a receiver. The receiver is the component that accepts the sucker rod assembly and a square shaft by which the rod string or the drivetrain can turn the downhole assembly. So then you have tubing with a guided rod string. So application, if we look at 100 horsepower, let's just do a theoretical evaluation. So if I limit the brake horsepower of the pump to 100 horsepower, I will use various pumps and assume a pumped off condition, calculate the discharge pressure. I'll assume a wellhead pressure of 250 pounds. So just in this theoretical analysis, we'll calculate the number of stages to meet the head requirement, calculate the pump horsepower. If that rate comes out, or that horsepower comes out more than 100 horsepower, we just readjust. So then from the pump horsepower, then you can calculate the pump torque, which is going to be at 3,500 RPMs, and that torque is going to be the pump torque times the ratio of the gearbox. So a speed increaser is also a torque increaser coming back to the low speed side. Then you also divide by the gearbox efficiency. So if you take all that stuff and put it together, this is the graph that you get. The blue line is a 100 horsepower curve, which is going to be pump depth versus barrels per day at that 100 horsepower limit. Then you can also see the torque that is going to be required on the rod string. So for a 100 horsepower system at 1,000, for 1,000 barrels a day, I can produce that from 7,000 feet. The same ratio, the same horsepower, at 1,000 feet, I can move 4,500 barrels a day with a 100 horsepower limitation. What are the unique traits of the geared centrifugal pump? We already talked about one of them. It's a bottom intake ESP. The other unique trait is the fluid load is carried by the tubing. The rod string is connected to the pump by a square shaft, and it's run after the GCP and the tubing is landed. Therefore, the axial load that you have on the rod string is just the buoyant weight of the rod string. So the axial load is small, so also the side loads that are transmitted to the rod string from the rods through the axial load are going to be small. But there's an issue because of that lightly loaded rod string due to rod instability at the receiver, and there's two things. There's an offset between the center line of the tubing and the receiver, as well as that bottom rod at the bottom essentially has no axial load at all. So with an offset plus being unloaded, when you turn that string at 500 RPM, you can imagine that rod being unstable. So that's an issue. The transmission. The transmission has large D channels to allow fluid